Hello everyone, I'm Xiao Gang. Okay, in the last lesson, we briefly demonstrated multicast. Now let's demonstrate some other methods. Actually, the remaining methods are more or less the same. Yes, but there is one thing worth noting. Actually, if you want the best approach, there is also this underplay method. Actually, okay, last lesson. Okay, I forgot to mention during the unicast lesson. It should be underplay. It is also an all-white, and it can receive corresponding parameters. Obviously, a variable is needed here. Otherwise, it's hard to find. We can just look for it in extra. Let's take a look at this method. That's it. Yes, this is the method. Then we just copy this part. Okay, then we rewrite this method here. You should also need to perform this operation in a single way. We make it underplay. Sometimes you forget, but this is a very important management, because after you bind it, although it can know a weak reference to this object, that's no problem. But sometimes you may want it to no longer execute. Then you might need to do this R, which is to unbind it. So here, we don't need this anymore. We have a remove here. Then we need to pass a handle here. Obviously, this AddObject will return a delegate handle. So we take this delegate handle, which is the myDelegate handle. Okay, we declare this handle as a member variable, so that during the life cycle, we can use it easily. This handle should actually be protected, because it is only a variable used internally. This step is still very important, although it might be, and whether you write it or not, sometimes there won't be a problem. But sometimes it will cause a problem like this. That is to say, sometimes an object of yours is already gone, but you haven't unbound this proxy, unbound this delegate. It is still sending messages in the channel. Then it might cause a crash, especially things you bound in the previous level. Then in your next level, all objects from the previous scene level are destroyed, but this bound proxy still exists. And sometimes problems will occur. So when it is underplay, we remove this thing. So doing it this way, it is very critical and important. Let me add this here for everyone. So then, let's continue writing here. We'll write a new one here. We'll demonstrate the other methods for everyone once again. We'll give it a more. Similarly, we will also do a simple binding. In begin play, let's go through them one by one. We'll cover them all in one go. Obviously, here we can directly pass a new delegate. This is also fine. Let's take a look at this proxy route. It should be possible to do it this way. It seems we can't directly do it here when creating. Then we'll ignore it. Still follow our method. Using this approach, so we just need to look at this, that big C. Because we need a parameter for this. So we'll write an extreme directly here. Ink. Okay, actually, when we print right here. Let's modify this a bit. This way, it prints the effect. Okay, here, some variables need to be processed. We don't need this so-called thing. We only need its RTL, then we delete these. Okay, so the first one is bound. Replace this here. Remove this comma. Okay, no problem. So that's the first one. Let's just bind them all at once. Otherwise, because this thing is related to our, it's the same. You can see here that you actually need to pass a blueprint class object. So we can drag one over from here. Just paste it. Then after pasting, we paste it into our place here. Then we can just delete these methods of the struct. Let's call it mu. Okay, then let's call this method create str, and it takes an input parameter, which is an f-string. Okay, in str, okay. Then printing is still the same. Let's paste this part over here. Let's call it row. Here, obviously, we need to create an object like this. Doing it this way is not very good, but it seems we don't have a much better way either. Let's just let it slide. We can just write it like this here. First, pass this pointer in. Then next, we pass the position of this function into it. Okay, that's done. Actually, we might want to do it a bit better here. Let's write it a bit more standardly. Let's move this thing to the front. Let's move it to this position. Let's try to ensure it remains valid throughout its entire lifecycle. Let's initialize it to null here. Let me do a simple check here. If it is null, we give it a value. That's a bit more reasonable. And in this place, let's do an underplay recycling. Here, actually for this underplay, we can do it like this. Let's just recycle it directly first. Let's get rid of the entire proxy first. We can do it like this. Clear it. Clear it. Okay, then if the native pointer we allocated on the heap still exists, we press delete, which is a simple C++ operation. We set it to null, for example, the resources we allocated ourselves. Okay, this is relatively more complete. Okay, doing it this way is fine. Then, looking further ahead, this is binding our smart pointer. Bind smart pointer down. Let's bind the smart pointer version first. Here we directly use TShared wave. We need smart struct point. Yeah, we can directly do it like this. Pass one in. Okay, this is a template, so we need to specify its type. Let me check. It shows there's a problem here, right? Wait, let's see where this problem comes from. Let me check how we wrote it before. We also pulled out a shared reference like this before. Oh, it was written directly like this. Hey, why do they look the same? Let's compare. There's an error prompt here. Let's check it. The error seems to be here. It seems to be affected by something else. If we have this delegate here, we need to delete it. Need to delete it. Because this delegate in the execute part here is inside the member. We cannot hide the variable inside the member. Okay, next, let's compile it again. See exactly where the error is reported. There's an error here. Think again about why there's a problem here. This is a bit strange. I'm not sure it might be. Maybe it didn't recognize this issue sometimes. I don't think I changed anything. If I just use it the way we did before, there shouldn't be any problem here. Maybe it's just a temporary glitch, not sure. Smart. Struct. Patil. Okay. See, there's no problem at this point either. Let's remove this. This is not yet what we are covering. At this point, it's just a way of writing a smart pointer. It's just a standard struct writing style. We'll explain it when we cover smart pointers. You see, we actually didn't do anything. We didn't do anything here. We just deleted and rewrote this piece of code. Something might have happened somewhere. Some strange issues might have occurred. Take a look. Actually, nothing was done. Okay, so now that we have a smart pointer here, we'll still bind it to this smart pointer. Later, in the first place, we'll pass this smart pointer. Then we'll pass this smart pointer method. Screen stream, okay. There's no problem with this. As for this screen stream, let's use a different method, a different way of writing it. Let's call it SP stream. SP, okay. Then we'll bind this method for it. This way, there's some distinction. Then we'll continue working on this, since it's relatively simple. We'll go a bit faster. That is, bind a lambda with a raw pointer. Let's just write a random lambda here. Then it must have an entry, extreme end strap. Speed it up a bit. Okay. Let's take a look. If it's this big, there's an error prompt here. Let's see what the reason is. The reason, actually, you can see it's here. This is a new one. New. But you know, here are single wave. You can see it's actually like this here. So this part is a pointer. Yes. Then, if we look at how it's used in the engine, you'll find that in most engines, it passes a this. It is called order delegate. Here, it passes a this. This should refer to itself, this thing. This is a slate. Yes. It usually writes this here. Not like how we write smart pointers. Okay. That might cause a slight issue. So let's take a look later. See if there are any issues. Let's compile it. Obviously, it won't pass compilation here. So we'll pass something similar as well. There's an error here. Let's see how to resolve this error. I've already handled it. I thought about it for about 2 minutes. Combined with the engine source code, we shouldn't write it this way. You'll notice how to think about it this way. Actually, you'll notice its function signature is a bit different. You will find that this part is like this. Anti-user, this new form of anti-Yazzie. Actually, when binding it before, you can see. Let's just click on this SP. It is bound in this form, pointer. This form of shared pointer reference. So this way of writing, you can see the engine. It is written like this. You can see it is usually inside a struct. To bind this thing, it passes the C. Why is it passed this way? Actually, it's because, look at this. It inherits from SCOMBand, inherits from SVG. SSA inherits from P2s from Z, mainly this thing. This thing will provide a Z. A method like NC2. So how do we simply modify this part to get this thing working for everyone? So don't write it like this. Then we added a shared pointer here. This is mainly for our convenience to hold it. This shared object, otherwise it will be absorbed. we will ignore this part. This can be converted into a weak pointer. Okay, so up to this point, there are no issues. Then here, we also add a T4C2 for 1Z. This way, it can be converted into a weak pointer. Can share this, and at the same time, this lifecycle is called initDelegate. Such a method. As for the implementation of this method, we will write it below. Write it at this position. And what is its purpose? It can pass an actor core in, pass this actor core in, then bind itself to it. You can say, right, only then can you compile successfully. So these are all quite special. So here, we need to do it this way. We already have a smart pointer here, such an object. Right, we do it this way. And then the binding here is done like this. We pass this. Okay, you can see it compiling now. There shouldn't be any issues. Of course, the execution should be more or less fine too. And then here, note this, it passes its pointer. It passes the pointer of this actor. Then after entering, this pointer finds this delegate. This is how you find this delegate. Then we take this pointer, and this pointer refers to this struct. And then binding this AddSP lambda should work. Okay, this part is a little tricky. This way of writing is relatively rare. It's not commonly used. Okay, let's continue working downwards. Next, we're actually pretty much there. This thread safe one is actually the same. Okay? It's just that we need to specify that. That is, we can, when creating, we can specify the mode when we share the pointer. Okay, let's do this static first. Let's just write a method here. Let's write it above it. We can actually call it, because this method has been written quite a lot already. Write it at this position. Let's give it a mute. Then there is an F string coming in. Let's place it like this. Okay. Then we put it in this position. Okay, so compiling like this should be fine. Okay, then let's continue writing the next one. Good, let's speed up. This one is thread safe. Its writing style is actually the same as before. It's just that it is thread safe. You see, then slow down a bit, maybe. So this shared pointer of yours must be thread safe. Then we might have to handle this part. A bit more trouble. So we might need to do it like this here. Let's declare another structure. Let's put this structure at the top. Note here, because this part can also be specified in add. This mode. Thread safe, and then mute. We give it a suffix called safe. Okay. Similarly, we will copy it like this. All over, paste it. Also touch here. Let's look at the name. Then we are here. Here we give a save. Okay, so this way we have redefined one on our side. And note that this place has a save. Save. Here we do it this way. We give it a suffix. Good. Note to align this place. I align here. Here, what we give is fill promote. Now let's add the method inside it. Then print. Okay, so it's bound now. But note, we haven't held a reference to it here. You'll see that we haven't made a shared pointer for it to hold it, so it will be destroyed immediately. Then if you check it, it won't actually work. So let's hold a reference to it here. This way we avoid problems. Then here we'll make a simple copy. We'll increase its reference count by 1. Let's see if there are any duplicate names. There shouldn't be a case of duplicate names. Okay, there is indeed a duplicate name. Let me check. Let's see where the duplicate name is. It should be here. This part wasn't changed. Yes, this place uses a TCR method. It needs to be changed. Okay, so it's bound here. Let's move on and look below. Okay, static. This UFunction and OBO are actually the same. Same situation. Let's still write it down. Let's write this UFunction. Very similar, we just passed this here. We pass the function name like this. My UFunction. Okay, so here we go to declare our UFunction. Put it in this position. We don't need it to be reflected to blueprint, so no categorization as needed either. This part is cool. Let's paste the name. Then there is an F hearts. Then we print the log here. For the log, let's keep it simple. My function, my UFunction. Okay, let's check that the log above should also be correct. We can also bind our OBO. Let's bind it to itself. As for this UObject, we might need to do it this way. We don't have this method yet. We need him to write such a method. It should be called the printinestria method we give him. Of course, it doesn't exist now. it itself makes me report red and normal. We just need to write it. Let's write it below here. We just need to simply change the name. Paste this name over. We create its implementation. As for the implementation here, is also just a call in the same way. Okay, no problem. So let's take a look next. What else haven't we executed yet? Here. Okay, there's also a wake lambda here. Let's see what parameters it needs. It needs a user object. Let's pass this. We'll just write the lambda like this. This lambda should be fine. Then fstream-inst. Then, same as before, we call this log. And don't worry about the order. Sometimes the order might be messed up, so we should try not to emphasize the order. Also, don't forcibly associate the logic with this order. Don't make a forced connection like that. That could cause some problem. The design should be done through other methods. Okay, so we're done here. Then next, we will take this and get it down here. We create a test entry point. Obviously, we only need to call this delegate here. This lesson might be a bit long, but you must remember that you absolutely need to if you no longer use these delegates. And this is a good habit. That is, your own resources must be released in a timely resources that are no longer used, because doing so later. This way, you will avoid bugs later on. There will be relatively fewer issues that arise. Okay, we have entered here, and it is worth noting. We have it here, and we don't need to add any new objects. We just need to let it call this method. Okay, we have a more. We can just let it execute directly. Okay, you can see the first one we bind is this. This order doesn't seem to matter. This is the native lambda. and the spiwa. That is, we first bind the native SP lambda, then this sep with the lambda. And this is the static method. This one is thread safe. This is the UFunctions. This should be the UObjects. This is the wake lambdas, and basically it corresponds to ours. Open this code in Cocoa and you'll see. Didn't find it, right? Obviously, the first one executed here. Is this lambda st? Then next is this native one. Then next is our spec. After sp, it goes into this. After sp, it's this sp's lambda. This is very special. I even saw about it for a while. This references the engine source code. This kind of writing has been written out, and this part is static. Then the thread save smart pointer. And this is a UFunction object. Then wake lambda. Okay, so we have finished the demonstration for everyone. Our part is actually okay. You can see it has been correctly acquired and released. Good. We will stop here for this lesson. Our multi-wave demonstration for everyone is complete. Actually, you can also just add a delegate directly. That's also fine. No problem. Or you can just do it like this. You should understand what I mean, right? That's exactly what it means. For example, if I do this kind of work here, I can completely do this like this. Make it something worth copying. Then in fact, this whole series of mine will become completely invalid. So this thing is equivalent to an object we bind in the scene. So finally, let me add one more thing. Remember, using K allows you to perform a copy and overwrite operation. Okay, let's stop here. Thank you, everyone.